All right, guys, welcome to Organic Chemistry. I'm going to go over what we've been learning this week, and we've been looking at the first section, which is nomenclature. So, if that wasn't clear to you, naming. Okay, it's our fancy word for naming. Um, what we're going to look at, it's not just naming, just giving them any name we want, but it's actually looking at system of naming. And this is what chemists all around the world use to name these compounds so that anyone could see the name and know exactly what it looks like. And what we learned from the other lesson is that carbon has 4 valence electrons and they are spread out in three dimensions. In the three dimensional, so you usually got one going up, one out to the side. You'll notice they do this thing with a dotted line, and that one is going back. And then they draw ones like this, and this one is coming forward. Okay, so these are the bonds. Now, the simplest one, methane, these could all be hydrogen, but carbon can also bond to carbon, 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 or they can bond to other things like oxygen and nitrogen, or even have have other groups attached. So generally, what we're going to look at here is the range of different carbon compounds we can make, and they've all got their own groupings. So we know, for example, alkanes. These are all the single bonds, so single carbon bonds. Alkenes, double. There's at least one. And most of the time, we're not going to give you more than one. Doubles, carbon bonds. So double in at least one. One in chain. Okay, so there's usually one. And this one, alkynes, was triple. I can't spell triple. Triple. C bond. And I'm saying at least one in chain. We don't want to make it two. We want you to just know how to do this. There are tricky things, and we've got a lot more difficult stuff in here. So usually we just give you one. Okay, you can have multiple. You generally don't have them on carbon straight after each other. So for example, if I have this compound here, it's very rare to get something like that. Okay, just because of energy and things. So generally we'll only have one double bond in the compound. Okay, all right, so moving on. So they're all our alkanes. These are all hydrocarbons, because they're hydrogen and carbon. Okay, the next group we're going to look at are these ones: alcohols, aldehydes, ketones, and carboxylic acid. These have oxygen in them. Okay. And then we've got this group here, and these ones have nitrogen. One of them also has oxygen, but we're just going to focus on the nitrogens. And the last one is one I showed you today, is halogens. So halogens, these are fluorine, chlorine, bromine, and iodine. Okay. All right, and we're looking at how the system works, and this system has been declared by the International Union, IUPAC, of Pure and Applied Chemistry. That's what IUPAC stands for. So they're the people who tell us what to do. We're only going to name things up to carbon 8. You're only expected to know those. And they also want you to know, including simple methyl and ethyl branch chains. Okay, and so this is what what the second activity in the week we're going to do. Okay, so if we go down, we need to know firstly number of carbons. So all the chains work on the number of carbons in your main chain. So the easiest one was 1 carbon and 4 hydrogens, and this is meth. They're all single bonds, so it's methane. Single bonds. There's you can't have methene or methine because there's only 1 carbon. You can't have two carbon, a double bond between carbons when there's only one carbon. So single bond between carbons, you can't have a double bond between hydrogens and carbon because hydrogen can only share one electron as well. So between carbons. And meth means one carbon. I am writing on my screen upright, so it does get a little bit messy. But just in case, just to make it sort of clear for you. So one carbon. Okay, and then when we get to two carbons, we have a different prefix. So this is a prefix, and the end of the word is a suffix. And we're going to be changing these in and out all the time. You saw a bit of this with inorganic chemistry, things that aren't carbon hydrogen based. So like carbonate or sulfur in a compound becomes sulfide, those sort of things. Or oxygen makes an oxide. That's changing the suffix there. Okay, so in this case, we're changing the suffix ane. So firstly, we'll start here, this one with 3, 4, 6, and that is ethane. One word, I'm just doing it in the thing. So eth, two carbons, ane, single bonds. Single bonds between carbons. When we say the single bonds, we're talking about that. If we talk about nitrogen and oxygen forms double bonds with carbon, but that comes later on. Okay, so we've got ethane here. If I have carbon double bonded, and now I can only have two carbons, I can't, because of this double bond here. Okay, one thing to remember is that carbon can only form 4 bonds. So when it has a double bond, each of those carbons will have one less bond with something else. Okay, so we can only have 2 hydrogen on this one here, because we've got 1, 2, 3, 4 bonds with carbon. So 1, 4 on that side, 1, 2, 3, 4. Check that when you're doing things because that is something people do get caught on. Okay, so ethane, this one is now ethene. This is a really important chemical. It's a precursor to so much of plastics and other organic chemistry, and we'll look at how we can convert it into lots of different things. So eth is 2, ene means double bonds. I didn't go too much into numbering where bonds are. We'll come into that today because it matches in with the stuff we were learning about where double bonds are, where our haloalkanes or where branches are. You need to number the carbon. So when we get up to 3, it makes it 4. It makes it easier. So ethane, and then the other one was ethyne, and that means triple bond. Eth still means 2. So we have 2 carbons, 3 bonds between them, and 1, 2, 3 means each of them can only have 1 hydrogen or 1 other bond. It could be a carbon, could be another thing. If there's a triple bond, in ethene there's only 2 carbons, so that's the whole compound. Okay, ooh, I need to go to make a new page. Sorry, I didn't consider that. There we go, made lots of pages, and let's just make them run into each other. There we go. And there we go. All right. So we have, we had method F, we have 3 carbons is prop. 4 carbons is bute, not but. Okay, bute, so there's no butanol or anything like that, sadly. 5 carbons is pent, and now we're going into stuff that you should be familiar with. I'm thinking of pentagram. Pentagon, hexagon, and heptagon, probably less familiar with, but that's for 7. And oct for 8. Non and dec for 9 and 10, but we don't need to go that far. 6 carbons, 7 carbons, 8 carbons. Okay, so they're our prefixes. And then our suffix will be, well, what type of bonding is between them. So if it's single, for example, this one with the hydrogens on it, this would be propane. If we get to 4 carbons, 1, 2, 3, 4, and let's say we have a double bond here, it would be the same as having a double bond at that end as well. Okay, then we have 2 carbons here, 2 hydrogens here, 1 hydrogen there because you've got 1, 2, 3, 4. So just watch, you don't always put hydrogens everywhere randomly. Double check when they're around double bonds and other compounds to make sure you're not putting in too many, because you would not get the mark for that drawing question. So this would be butane. Oh, sorry, butene. What is wrong with me? Butene. But also, that whole numbering thing that we've been looking at is that double bond could be there in the compound, or you could actually have a double bond between the 2 middle ones. So we need to define whether it's on the end 2 carbons or in the middle. And this is where we number them. So starting from here, we'll call that number 1, that number 2, that number 3, that number 4. We could always start counting from this end too, but then we would end up with 3-butane. And then, why call it 3-butene when you can call it 1-butene? So always go for the lowest numbers. If that double bond was on here, it would still be 1-butene, okay? Because basically, these are 3D. They are things you could literally turn it around and it's still the same molecule. So that's 1-butene. And just to give you an example of what 2-butene would look like, sometimes this is just a little bit more tricky than I need. Okay, so 2-butene will just have that double bond between the 2 middle carbons. And this is the same rule for alkynes as well. So I only need 1 hydrogen there, 1 hydrogen there. And you still have the same number of hydrogens as in those general equations. So for butene, this would be CnH2n. So carbon, I have 4 carbons. So hydrogen, I have 2 times 4, which is equal to 8. So C4H8, is that what I have here? 1, 2, 3, 4, 5, 6, 7, 8. That works. Okay, so that's how you check your molecular formula. All right, so there we've got, so I'm going to stop at this point and go, we've numbered our double bonds as well as being able to write the prefixes and the endings. So ane, ene, and ine. All right, when you come back, we'll do branches.